Well, hey everyone. I'm excited to share with you some of the results that Dan and I have been working on over the past year or so. And these are kind of just coming back home and looking at the Earth, because really throughout the majority of my graduate career, I've been thinking about planets that are not Earth, planets that are orbiting other stars specifically. But it's nice to come back as my final chapter of my thesis to look at how could we think about the Earth in thinking about other planetary climates. And one of the most major things that we can we can find as we look at Earth's history is the evolution of the O2 abundance throughout time. And this is primarily due to the rise of photosynthetic life and as well as biogenic feedback. So really the question, this is still in the forefront research in Earth science, right? We don't know how the rise of oxygen came to be. And is it individual events, different individual events, or is it these feedback loops that we still don't understand? So because of the potential diversity of different oxygen levels, it expected that as we look for these young Earth-like planets, we were essentially looking at different snapshots of their history. So it is very likely we're gonna get a whole bunch of different oxygenation levels. So we kind of use our the 3D chemistry climate model that we've developed over my PhD and look at this problem. Basically, very simple, changing just the global oxygen concentration. We find that actually, interestingly, depending on the nature of the climate itself, the changes in global oxygenation level can have a very significant effect on specifically the water loss timescale, which is the number of years that the planet could hold on to water. So in this case, we show that for wet climates, namely planets around G-dwarfs, we find that as we increase the O2 mixing ratio, this is present day atmospheric level, as we increase it to the present day level, basically imitating what we see here, as the planet gets more oxygenated over time, the water loss timescale actually increases. Conversely, for dry climates, there's the opposite effect. The water loss timescale decreases. This is something that we've been looking at, a very important effect. We're looking at what is causing the effect as we speak. And these results actually just came out a few days ago. And I was really worried I wouldn't be able to get it in time, but I was able to. So really happy about that. I'm excited to announce that I'll be moving to Goddard actually in January if I successfully pass my defense, hopefully in person in December. And there I'll be working on kind of instrumentation and observation, I'm a modeler on a team, but I'll be working with people who are building telescopes to look at potential habitable worlds in the next few decades. And obviously NASA has a lot of centers. I'll be moving to Goddard at Greenbelt Mountain. And one of the things I've been working on there is to look at what can we actually see. So I've done a lot of work throughout my PhD with Dan on simulating climate of different planets. But what do they actually manifest in a spectrum? Because we don't actually image these planets, right? We take snapshots of their atmospheres. Namely, we use spectroscopic tools to understand their composition. So that's kind of an indirect way to look at atmospheric composition, but this is the best we can do for James Webb. So my work in terms of building the models is to specifically look at how can clouds and aerosols, which are these condensates that come from depending on water, depending on the CO2 concentration, that kind of stuff, and really the temperature and how these molecules can condense, and how these different types of molecules or condensates of the molecules can affect what we actually observe. So this is my work, and this is shown to be very important by a postdoc at University of Chicago, looking at the effects of clouds on amateur emission spectrum. But this is with a one-dimensional. So in the future, I hope to develop, translate my 3D chemistry climate model outputs into some of these observables we can see, and use simulated clouds to look at how can clouds affect the observation. I think this is very important moving forward for the community to look at these important predictions that will be happening in the next few years. Thank you very much for your attention.